Hello and welcome. Here we are. Let me just ensure that this is working before we begin. So today we're going to do more LeetCode problems. And this should be kind of fun, kind of interesting. I've been really enjoying doing this lately. I don't always have the time to do it, but when I do, I try to take advantage of it and try to do this. So let's see about the I've been really enjoying doing. Yeah, the audio seems okay. Okay. Stream is healthy, audio is okay. Awesome. Let's get going. So, should be able to see everything. Yeah, ready to go. All right. First one. Let's go. This is going to be the easiest questions first. Or the easiest questions on LeetCode. All right. Total waviness of numbers in range 1. Two integers num1 and num2 representing an inclusive range, num1 to num2. Waviness of a number is defined as the total count of its peaks and valleys. A digit is a peak. It's strictly greater than, oh, okay, so it's digit waviness. All right, interesting. First and last, so valley if it's strictly less than both of its immediate neighbors. Peak, it's greater than both. First and last can't be peaks or valleys. Any number with fewer than 3 digits has a waviness of 0. The sum of waviness for all numbers in the range num1 and num2. Oh, that's an interesting question. Okay. So interesting. And the range is going to be between 1 and 100,000. Okay. Oh, this is a very interesting question. Okay. Can we do this more efficiently? This is sort of a math theory, number theory kind of thing, because I could just process every number in the range and take the sum over the waviness. That's one possibility, and that'll be sufficient for this problem. It'll work. It'll be correct. But maybe there's a more intelligent way to do this. Maybe I can use dynamic programming of some kind. Let's see. I'm thinking, like a kind of more naive brute force approach definitely works, but whether or not I can improve that to a more number theoretic approach. Ooh, okay. Let's think about that. Excuse me. Well, when I increment the number, a number, I could do it alternatively, the total waviness up to a certain point, and then just subtract the 2. That'll give me the range. If I do it that way, then I might be able to pre-compute all the waviness up to 100,000 with a prefix. That's a reasonable way to do it. Let's try that. Let's do pre-computation. Yeah, let's do that. Let's do it that way. I like that. That's an easier way of doing it. I don't know if it's the easiest. So let's just do that. Computer's kind of lagged, which I don't like. I think I need to reset my computer soon. I think this is a pretty good way of doing it. I actually think, yeah, let's just do. And then we're going to also have. Okay. And then we're going to return prefix of num2 minus prefix of num1 minus 1. Yeah, I think that's fine. That works. No. So we'll come back to this. We can do it this way. Calculate waviness, constant x. And we're going to say for int I equals 1, I is less than or equal to less than 1001. Set waviness, so I, let's calculate waviness of I. And then we're going to say prefix amount 0. And then say prefix I equals prefix. Okay, something like this. And then calculating the waviness, we're going to say we can use a dump. A digit dump. And this will be up to 100,000, I think. How many digits? I think it's 6 digits, right? 6 digits. So we're going to mem set the digit dump to 0. We're going to say for x is greater than 0. I guess we do have to actually have an index widget this way. Okay. So the least significant digits will be left to right. And then we say, let's also have an n. I will keep track of how many digits there were. I is less than 3. Actually, you could do x is less than or equal to 3 digits or less is going to be 1,000. Turn 0. Let's create our digit dump. I'm going to say int result is 0. Int I equals 1 to I, or no, so j. J is less than I. Increment j, and actually it's going to be j plus 1 is less than I. And we're going to say result plus equals. Now the waviness is it's the total of the peaks and valleys. Okay. Constable peak, constable valley. It's going to be digit dump of, or we'll just say dump. It's a little easier than digit dump. Actually, no, we'll keep digit dump. That's fine. That's fine. All right, it's going to be digit dump of j is greater than digit dump of j minus 1 and digit dump of j is greater than digit dump of j plus. Okay, and then a very similar expression for a valley. It's less than both peak or valley. So it's one or the other. And then we return that result. And this is something along what we're looking for. So how are we doing with doing this lately? I don't always have the time to do it, but when I do, I try to take advantage of it. Let me see. I'm trying to do this. So let's see about the. I've been really enjoying doing it. Yeah, something like this. Okay, there we go. It's a little bit. What's the word for that? It's a little bit of it's a little bit of what's the word? It's a little bit of what's that called? It's a little bit of I'm sorry, my brain, I'm all over the place. I'm thinking about too many things at once. When the live stream buffering, that's what's called, a little bit of buffering. I couldn't think of it for some reason. It's taking so long. It's a little bit of buffering. Okay, waviness prefix. So precompute. Okay, for some reason this is incorrect, and it's not clear as to why. But yeah, it looks like we'll perform once. The waviness. Excuse me, if it's less than 3 digits, not 4 digits. So 3 digits. Less than 100 will be 0. Okay. So this is a fairly straightforward solution. I can try this, see how it goes. This is basically using pre-computation and to try to get a fast solution. Okay, it's as fast as it can be anyway. There may be a better way to do this, but this is pretty good. This is pretty good. I like this. I was hoping maybe I could think of a number theoretic approach that would be a little bit faster, but this is already extremely fast. So I think that's okay. Looks like it might be still having some issues with buffering. Let me see. Yeah, having some buffering issues. Looks like a mixture of potentially buffering and throttling. I don't know. All right, let me continue. That was cool. That's as fast as it gets for those constraints. So that's okay. I could potentially think of a faster way, but that's probably about as good as it gets. Okay, separate the digits in an array. Given an array of positive integers nums, return an array answer that consists of the digits of each integer in nums after separating them in the same order they appear in nums. To separate the digits of an integer is to get all the digits it has in the same order. For example, if the integer 10921, the separation of its digits is 10921. Okay. Okay. I mean, this is Oh, interesting. Okay. Oh, that's kind of cool. All right. Huh. Um, the numbers could have 6 digits each. So, okay. Okay. So I think we kind of just do almost explicitly do what they ask. Um, yeah, I think it'll be. Could use this static dump. Dump. Go digit dump dedump. Um, right, 0, increment I, divide equals 10, dedump of I equals x mod 10. Excuse me, and then we just go backwards. Something like this. I think it's like this. Oh, one mistake here. Oh, actually, it doesn't matter. I was gonna say I could mem set the dedump, but actually I don't need to. I don't need to do that repeatedly. Only need to do that at the beginning, I think. I'm gonna go for it, see how it goes. Um, Stream's still having issues with frames, dropping frames, stabilizing. Okay, yeah, that's pretty efficient. That's fine. All right. Check balance string. Given a string num consisting of only digits, a string of digits is called balance if the sum of the digits at even indices is equal to the sum of the digits at odd indices. Okay, I mean, yeah, it's pretty. So odd, even, how large is the string? Digits are on the smaller side. It's small. Yeah, okay, this is fine. So 4 and type 0. Dot size. This I think also is like a very fast kind of a problem. I plus equals 2. I plus equals num of I. And I don't need to modify these very much either. Like normally I could take the digits and say, normally I would take the digits and say, like remove, turn them into remove, oops, 0, 1, 2, so 3 plus 3 is 6, 4 plus 2 is 6. Oh, I see, I do actually need to do that, never mind. No, never mind, I was right. Oh, I was wrong about that, you need to subtract. Never mind. I was gonna say converting the. I thought initially I could skip converting the characters to digits explicitly to digit integers, but Actually, I do need to subtract it because if there's a different number of digits being considered between odd and even, then it doesn't calculate correctly if I don't make that change. Okay, I thought I could skip that part, but I was wrong. This is probably about as fast as you can do it too, by the way. Okay, maybe not as fast. I got 1 millisecond. My code is slow, man. There you go. Okay, 100%. All right, it's fine. Keep going. Stream health a little bit better. Excellent. There we go. Okay, that's good. Whew. All right. Hexadecimal and hexatrigesimial conversion. Oh boy. Okay. Determine the concatenation of the hexadecimal representation of n squared and the hexatrigesimial representation of n cubed. Okay. X number, base 16, uses these digits. Hexatrigesimial, base 36, that uses 0 through 9, and the uppercase letter A through Z. Okay. So I've got to do n squared and n cubed and concatenate these two. N is between 1 and a million, so 1 is 1,000. So squared will be a million and cubed is a billion. Okay, this isn't too bad. Const auto. Let's do std string s, or results rather. Result.reserve. Let's do just base 10, I think. It's gonna be n squared and n cubed. The logarithm of that. Log base 10. Interesting. Okay. Squared. Size. Let's do toString square. Size plus the toString of cube size. All right. Result reserve. Okay. Let's go with that, I suppose. This isn't that fast, is it? No, it's not. Okay. Let's actually do. Let's do it this way. Gonna just assume 100 squared is 6, right? And 1,000 squared is 6 or 7, and then 1,000 cubed is 10. So we'll do 17. We'll just do a flat 17. All right. Form. These actually should not be const. All right, we're gonna do square greater than 0. If square equals 0. Square is greater than 0. else result dot pushback 0. I wonder if I can do it this way. Now we're going to do square divide equals 16. Square mod 16 is content hex. And we're going to say, okay, if x is greater than 9, then char ch is going to be hex plus it's greater than 9, we're going to add an a, otherwise we're going to add a 0. Could do it this way. Might be optimizing this a little bit too much. So if it's greater than 0, greater than 9, then we would add a, unless we had 0. That's the same thing for the square. And we do the same thing for cube. I think it is always greater than 0, though. I don't think I need to worry about that edge case. Yeah, it's always greater than 0. That's a redundant edge case, a necessary edge case. Yes, it's reasonable. It's kind of the same code for both. All right, how do we do here? What's up, chat? What's up, code guy? Hey. Howdy. Howdy. Hope your day is going well. Welcome, welcome. How are you? How are you? I think this is similar thing. Cube, square, result. Let's try this. How is the still buffering? A little bit of buffering. Oh, okay. Oh, look at that. Okay. This should be capital A, I think. Also, square mod 16. Hex value. Oh. I need to subtract 10. I think that might be correct, actually. Wrong. this one's wrong. What do they call this? Is hex, and then there's hexatri, hexad, hexadecimal, and then an hexatrigesimal. Okay, let's try again. Kind of a mistake on my end here. Keep getting at symbols and getting the wrong numbers. Let me try to think about this conversion again. So if it's 0 through 9, then I would add this character to that amount. If it's 10 to 15, though, then, oh, that's why. These are wrong. These are the wrong spots. That's kind of subtle. Oh, I was gonna say, I think I messed up something there with the editor. Okay, still wrong, but better. Okay. 9A1 rather than A91 B1. Okay. Interesting. Why 13 squared is 169, I think. 169 and hex is, let me see here. Divide or mod 16. Oh yeah, there you go. I think it's 9 initially. So the first value is 9. Oh, okay. I'm pushing these things in the reverse order, I think, is the issue. Oh. I mean, the first one I can reverse, but the second one needs to be reversed as well. I guess I could do this. Int k equals result.size. Still reverse result. Begin result.end. And then so reverse result.begin. It's k. I could try something like this. This is taking quite a bit longer than I was expecting. There we go. Let's try a few other cases. I think I'm getting too hot and I need to take my shirt off here. Let's try this. Yeah, that looks fine. Okay, I'm gonna go for it. See if we're still buffering. Not as much, but a little bit of buffering, not as much though. Sweet. Yeah, that's pretty straightforward. That's not too bad. Data frame from a list. Let me take my shirt off. Give me one moment. Yeah, there we go. Get comfortable. Take my shoes off, take my shirt off, get comfy. Solution to create a data frame for a 2D list called student data. This 2D list contains the IDs and ages of some students. The data frame should have 2 columns, student ID and age, and be in the same order as the original 2D list. The result format is in the following example. Okay. ID and age. Okay. So I don't know very much about Pandas syntax, but should be able to do this. Okay, so let's look up creating a data frame in Pandas. Let's learn more about that and see what we can do. Well, doing okay so far here, I think. Pandas data frame is a 2-dimensional tabular data structure similar to a spreadsheet for an SQL table. Primary object used for data manipulation in Python. Create one using the PD data frame constructed with various input types. Dictionary of lists, common method, dictionary becomes column names, values become column data. Okay, common method. Just create the data frame directly. Okay. List of lists, row-oriented data, explicitly define column names using the columns parameter. So this is what we're doing. Data, columns, data frame. This is what we want. Oops. Let's see. DF. PD data frame. That's going to be student data. Then columns. What do we say? Age, student ID, and age. All right, let's try that. List of dictionaries. Ideal. Each dictionary represents a single row. Keys automatically become column headers. Cool. Very interesting. Unexpected columns. Columns. All right, let's try again. Okay, this looks correct. We'll go for it. That is a syntax question, which is good, which is fine. Learning the syntax is totally fine. All right, keep going. Finding the user's active minutes. Okay. Given the logs for users' actions on LeetCode and an integer k, the logs are represented by a 2D integer array of logs, where each logs y equals id of I. Time I indicates that the user with ID of I performed an action at the minute time of I. Multiple users can perform actions simultaneously, and a single user can perform multiple actions in the same minute. The user active minutes for a given user is defined as the number of unique minutes in which the user performed an action on LeetCode. A minute can only be counted once, even if multiple actions occurred during it. Interesting. Calculate a one-indexed array answer of size k such that for each 1 less than or equal to j less than or equal to k, answer of j is the number of users whose UAM equals j. Turn the array answers described above. Oh, that's kind of complicated, huh? Bit of constraints. Pretty high acceptance rate. It's, logs is 1,000. The IDs can be up to 1 billion. Times been more than 100,000. K is in the range, the maximum UAM for a user, and 10,000 or 100,000. And I think K is what they're, no, K is the array size K. Do they give me a value for K? Yeah, they give me a value of k. Okay. Number of users whose UAM equals j. So the frequency, basically, for the UAM of the users. User UAM frequency. Okay. Sure. So ID 0 performed actions at minutes 5 and 2 and 5 again. UAM of 2, minute 5 is only counted once. Interesting. Interesting. Huh. Um, hmm. Uh, I mean, shoot. I'm trying to avoid using a hash map. Hmm. Well, it's kind of hard to avoid using a hash map. The reason I might want to use a hash map is that I can just associate each ID with each minute, and at each minute just increment each ID that has an action there with the minute in that minute, and just be sure to increment it only once. And then later I can read off those values into the UAM frequency. But I want to avoid using a hash map here if I can. I could try just taking the IDs modulo like 10,000 and then handle the collisions separately. Could try that. Let's think about this. The hash map works here, but I think a faster approach would be use like a custom hash. Basically hash the ID to something in the range of 10,000 or 100,000. And then there could be collisions. I'd have to handle that appropriately. Hi, good to see you. What's up, Yash? Hey, howdy, howdy. It's good to see you as well. Or good to chat with you as well. Communicate. I don't know. Chat's good, maybe. Chat. I'm trying to think of a better way to do this stuff. We could just do it with a hash map and see how fast it is. I mean, it's only 10,000 logs, so it should be okay, I think. I think it'll be fast enough. I think we could just use a hash map. Fine. All right, we'll use a hash map. Actions or minutes UAM. We're gonna say for const auto b and logs hint d 0 minute is 1. Say UAM of ID plus. I kind of need to keep track of the minutes that were used for that ID. Could do, this is a little more, I'm not sure about this one, but could do it this way too. There's one way of doing it. This is one way of doing it. This kind of handles a bunch of things simultaneously. And then we have so we can get the size of the unordered set, and then we can say result of k of amount plus plus. I want to say it's something like this. It's a bit wonky. It's a bit wonky, and I'm not sure it's the most efficient thing. It's probably not very efficient, quite frankly, but threw an extra D in there also. Wrong. Okay. Let's see. Oh, I think it's one indexed. I think K is one indexed. Yeah, it's one indexed. So that means this should be K minus 1. And this should be plus 1. Or no, minus 1. Shoot. What's up? Oh, we'll read in a second. Was interviewing for some internships and received a response back from one. Oh, it's awesome. There you go. Interview assignment. They want me to create an end-to-end, fully automated cold outreach pipeline. Wow. Okay. And that within 4 days, they're the AI startup, I think. Okay. That shouldn't be too hard. Cold outreach pipeline. That's the assignment. Is it a take-home assignment? You could do that in 4 days, I think. You could probably do that in 1 day, actually. Really go hard. Oh. I guess I do need this. Okay. I'm going to go for it, see how this goes. I would need a little bit more information, though, on like what exactly they're expecting as far as like the pipeline. 51 milliseconds. Yeah, this is really slow. This is really slow. That's kind of what I was afraid of. I was like, I'm pretty sure I can get this solution, but this is slow. Okay. AI startup, interesting. Yeah, I would definitely want to ask a lot of questions as far as like what they need, what they're expecting, how they want the how they want all that to work. But basically, you could just integrate one of the like the APIs, the to automatically generate emails, that sort of thing. Could even have a voicemail. I don't know that. That might not be. I don't know if that's legal, but automated emails is probably legal. Cold outreach is a little weird though. You have to like scrape information where people can actually be reached. I mean, you could do phone calls, automated phone calls, automated emails. These things are fine, I think. It's actually kind of on the easier side, I guess. I don't know. I have to think about it, but you'd probably have to ping an API, ping a or make use of one of those AI APIs. You could get. You could use like a local model. That's one way of doing it, like quantized local model. I can generate like basic outreach emails, or just cache your emails, cache your like cold approach parts, and then do caching is probably the easiest. You can use an AI to generate a whole set of things, cache them, and then you need to get the people you're going to reach out to from somewhere, how you're going to reach them, and then you just deliver the message. Email lists are probably the easiest. Like I said, you don't actually need to query an AI API directly, like real time. You could do it like sort of off, like statically, or like do it beforehand. So that way you have like a whole list of things. There's a whole bunch of stuff you can do there. There's a bunch of things. A few different ways to do that. But yeah, if you need AI though, you could use a local model. It's quantized, I think, and you can use their open source like text to speech type things you could use as well. So if you wanted to use phone calls, you could. Oh yeah, that's what I was going to say. Is to do the. I mean, you could just record your own voice too. That works too. You just transcribe it yourself beforehand. Like I said, if you use canned scripts. But if you want to do follow up, and once it's a little more engaging, you can have other options. There's a lot of ways you could do that. All right, so how to make this fast though? It's gotta be fast. So this is so slow because of the unordered set, and this just makes everything distinct. I can't just increment here as an integer because there could be multiple actions from a user on the same minute, same ID, same minute. Is that right? Yeah. I guess if I just remove duplicates from the logs. Could do that. Mm-hmm. How about this? Did you also watch that I was laid off by Atlassian video? It made me realize experience is the best teacher. Well, mistakes teach you one of the great lessons. Yeah. I didn't watch that one specifically, but I'll probably see it at some point. I think I probably did actually see that somewhere, but didn't watch the whole thing. Runtime error. That's not good. Sort the logs, get the pointer, and then maybe I should sort by minute. No. This is an interesting question. There's like a few different ways to think about this, I think. Runtime error. Huh. Hmm. Okay. I'm actually not too sure about this. Might be something weird going on here that I don't realize. Let me try this. But yeah, making mistakes is not a bad thing. No. Hold on. Ask the AI what it thinks here. What did it say about the other stuff? You learn a lot from mistakes, believe it or not. You tend to learn more from mistakes than you do anything else. Correct and optimal hash map required. Complexity, logs, style, redundant. Okay. Critical logic error, crash. It's not resize the container. Oh, it's the end of the range. Whoops. Whoops. I forgot about that. Okay. Whoops. That would be the issue there. I was like, I'm missing something important here. I'm missing something important. It does cause a crash, which is interesting. Okay. Whoops. There we go. All right, let me try this one. What does it say? Still kind of inefficient, but the upshot to doing it this way is that now I can use an int. And this is better, I think. Right, that was the optimization I was going for there. By removing the log duplicates. Okay, yeah, that improves things a bit. Okay. I have to see. I've probably seen that video, but have to poke around for it again. Main suboptimal, the pure hash map approach. Less optimal. Okay. Cleaner and more efficient. Okay, creating all this hash sets. Clunky and expensive. Just to remove duplicate logs. Hmm. 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 Avoid the hash map entirely. Count the runs directly after sorting unique. Oh, that's a good point. Oh, that's a good point. It's sorted. Logs. I didn't even think about that. That's clever. Ah, okay, there you go. Like that. Like that approach. Okay, hold on. So I think there's a way to use like a bucket sort version. Radix sort. There we go. Okay. Interesting. Interesting. Hmm. Cool. Interesting. Very interesting. Nice. So that was one of the things that I missed, is that I could sort it and then directly count the runs. Um, do scan. Makes better. F. And at the end, we're going to say result. I think it's something like this. Something like this. Oh, okay. Oops. Okay, something like this. Love you, for you, love you from Pakistan. What's up? A coding bug. Hello, hello. Good up, sir. By the way, what's your rating? It's reasonably. Oh, my rating. I don't do the contests. So I don't have I'm unrated at the moment, but my rank is this one. I appreciate that, by the way. Okay. What did I do? Uh, I managed to get a runtime error. Okay. Hmm. What did I do? What did I do? I don't know if I need this for part, actually. That might be the issue. Might be that simple. No. Not sure what's going on here. Let's debug. I could throw it in the AI. It'll probably tell me something, but it's good to just debug this and see. Let me see. Okay. What did I did something wrong. I don't realize is wrong. Okay, 0, 1, and then I have an error. Oh, there are only 2. Should be 0, 2, 0, 5, 1, 2, 1, 3, and then it goes back to 0 again. Oh, I know it's wrong. I know it's wrong. I know it's wrong. That's kind of subtle. I don't use pointers that much. I use pointers, but I don't use it that frequently. I'll miss something like that. This actually needs to be on the other side. Okay, let's see. Bruh, I am also a coder learning coding Python. I am teenage, so I will start TP. Bruh, do you know Tourist? What's up, man? I'm sorry, I already said hello before. Also learning the code. Cool, that's good. I don't know who. I think Tourist is a competitive programmer, right? Oh, there we go. Okay, this is better. Oh no, that's not better. Excuse me. I looked at this and not this. Misaligned. Oh boy. Uh-oh. Uh-oh. I think I've heard of Tourist. I think he's a competitive programmer. I think he's Russian. Wrong answer. Okay. There we go. Okay, now I think I got it. I think I got it now. Basically some off by 1 errors here. There's Tourist. There we go. Beautiful. Let's give this a shot. Oh, shoot. Okay. So this is relatively concise code. It's not the fastest, though. Stage name. Huh. What about the programmer? I'm pretty sure it's supposed to be. Alright, I mean, it's relatively fast. But not the fastest. Legendary handle. Oh, Korotkovich. Yeah. Oh, he's the. Yeah, I was gonna say he's actually extremely skilled. Belarusian, not Russian. Belarus. Yeah, I know. I know of Mr. Gennady Korotkovich. Give me advice for starting CP. Gotta read algorithms. Spend time reading. Like I actually kind of hybrid. I do it kind of hybrid. You see what I'm doing? I chat with an AI, and the AI gives me the stuff to read, and I read while I go. I do kind of a hybrid approach, but gotta do lots of reading. Optimal implementation. Code is excellent. Oh, thank you. Yeah. It's dominated by the sort. Likely the fastest possible. Okay. Interesting. It's not the fastest though. Not to be the fastest, however. What do you think? All right, let's see if I can find things I could do to make it faster. And by reading, I mean reading algorithms, techniques. I don't see too many ways to optimize this. This is pretty optimized. Into arrays. Yeah. Highly optimized hash map, even raw array if IDs are small. All right, let's see what the optimal solution is. It's a pretty good solution, but it's not the fastest. So we'll find out. Yeah, it's pretty good, but not the best. It's the best. Let's see what the best is. So they use custom sorting, log count. Maybe it's the pointer arithmetic. The optimal solution also uses similar line. Maybe I'm losing some speed. I could try to use fast IO. Okay, let's try to use fast IO. I don't know if fast IO actually matters here. I don't think so. I might as well. Okay. I'm going to call this N. Okay, let's try this. Added fast IO and not losing speed. Hmm. 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 Takes vector puts directly. Okay. Std vector versus std pair. Likely the true culprit. Hmm. Oh, interesting. Exact same machine code. Hmm. So just dump it into flat logs. Cache misses. Like dumping the logs to flat structure. Hmm. Could try it. Oh. Flattening. Hmm. Wow. All right. Well, there's an idea. Okay, let's try it. Um. This could be unique too. This could be static too. Yeah. Okay. Okay. So now this is going to be the flat logs. Okay, let's try this one. What motivated you to start streaming and doing programming in public? What's up? Yes, that's a good question. That's a great question. I appreciate you asking. It was a mixture of things. So it's kind of a long kind of journey of things that happened, but I think it came from watching other people live stream, and I saw people make a lot of money live streaming, and I was like, I like money, I should live stream. But I wasn't very good at live streaming, so then I was like, well, I'm good at programming, I'm good at math, so let me try to do some of that. And I eventually combined the two and ended up where I'm at now. Many years later. Kind of a slow evolution of things, I think. Error to call the constructor is ambiguous. Okay. Is this the ambiguity? Wrong. Okay. It's not ambiguous, but now it's wrong. Whoa. Incorrect answer now, though. I wasn't expecting that. Oh, that's probably because that was a typo. A slight typo there. There we go. All right, let me submit this, see how it goes. I appreciate you asking, by the way. Oh, look at that. Oh, how you like that? Mmm. Oh yeah. Oh yeah. Best solution was 7 milliseconds. Mine is 0. Oh baby. Oh man, that's a good vibe. Oh my goodness. This one got 0 milliseconds. Meanwhile, the top solution, 7 milliseconds. Oh. How you like that? How you like that? Dude, I didn't just get the top solution. I blew all the other solutions out of the water. Oh, that's amazing. It's a key trick, static buffer reuse. That's crazy. Wow. That's wow. I gotta remember that one. That's a really fast solution. Holy smokes. That's crazy, man. That's crazy. 100 just 0 milliseconds, 100% easy. That's wild. That's wild. So cache locality, okay. Wow. Dynamic memory allocation is one of the most expensive operations. Okay. Purely CPU cycles for sorting and scanning. Is not thread safe and relies on the judge running test cases sequentially in the same process. Real world production environment or a multi-threaded server using a static mutable buffer like this would cause race conditions and data corruption. In theory. In theory. Judge specific optimization, general software engineering best practice. Wow. That's not true. Could just use New Texas Atomics. Multi-thread safety. Edit. Could additionally allocate more memory. Copies of the static buffers. Other threads to use. Granted, it's more memory. Still operates the same way. So I used to play Warcraft 3, and I used to work on custom maps, which I noticed there's some people live streaming their custom map work now on YouTube, which is really cool. Um, but multi-unit instantiable is the term that comes to mind. So there were a lot of issues with Warcraft 3's coding engine. And it's this idea of making something MUI is very similar to what I'm describing here. Like one of the ways that I would do it is that I would create copies of all the data arrays and data variables that I was using. I would make another copy for each unit that was usually like it would be like spell making would be the idea. So in the game, a unit casts a spell, and you want each spell to operate kind of uniquely on each unit. And so you'd basically create like a copy for each unit. And one way of doing this would be to just basically turn all of your data into like arrays of data. And then the unit index would index into that array. So each unit would get its own kind of instance. It's very similar to like classes in object-oriented programming. Yeah, mutex overhead problem, thread local. Thread local is what I want. Oh, okay. Let's do thread local then. Let's be super fancy engineers. Thread local. Doesn't even get highlighted. Does it still work? Yeah, 4 milliseconds is still 100%. That's pretty wild. That's 0 milliseconds, that's awesome. So yeah, it's still thread local. That's what I should use instead of static, is thread local. Getting pretty good at this, man. So it looks like we also kind of got like a very lucky kind of run there. We got 0 milliseconds out the gate. It looks like it doesn't always get, yeah, okay. What if I go back to static? Maybe it optimizes static a little bit, I don't know. No, that's the same. Okay, so it is the same thing, but that's really cool. Perfect sweet spot. Completely thread safe. Okay. Standard pattern for high performance C++ and multi-threaded servers. Great choice. Thank you. Thank you. Okay. So it looks like, I don't know, we're going to get the 0 milliseconds again, but that was pretty cool. That was pretty cool. How are we doing? Stream health. Okay. Yeah, I don't know. We're gonna get the 0 milliseconds again. That seemed like it just randomly happened to work very nicely. That's cool, man. I like this. I like this. I'm wondering if an integer array is better of pairs. I suppose this is fine. It may actually be even faster if I modify this slightly. All right, so that's pretty amazing. So yeah, flattening. I'll keep that in mind. That's a pretty good thing to learn here. Okay, it doesn't always give me the optimal speed. Interesting. So I got kind of lucky the first time when I got 0. It seems. I don't consistently get 0 milliseconds, but I got it that one time. It's cool, man. Very cool. Very cool. Okay, so that's something to keep in mind. Okay, very cool. Then new challenge. Have to keep in mind dumping data into a flat structure, like a vector of pairs, allows reduction of pointer chasing, highly optimized solutions. Very cool. That's amazing. I'm gonna do this one more time, see what I get. So thread local is something that I learned today, and then I also learned that flattening data structures matters quite a bit. It's quite a bit. Coding is no different from art, like a magic that is wielded to create the unforeseen at will. Dude, that's what it feels like. That's what it feels like. This feels like freaking art, work of art over here, for sure. I wouldn't say it's not. It is different from artwork, but this does definitely feel like like creating artwork over here. Yeah, it's true. It's pretty amazing. Powerhouse for competitive programming, low latency systems alike. May your future solutions all be 0 milliseconds. Yeah, so this is, we're gonna get a new conversation. Hello, amigo. I'm actually gonna truncate it. Oh. Oh no. Uh-oh. Uh-oh. That's not supposed to happen. Uh-oh. Uh-oh. I pity those who think otherwise. That's probably true. Yeah, that's probably true. Okay, here we go. Hola. Hola, amigo. Hola, 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 amigo. I don't think that's how they spell that. I wonder what it says. Hola. Oh, that's the one. Hola, hola. Okay. It's hola, amigo. That's the one. All right. I don't know how to spell it, so hola is the one. Hola, amigo. All right, I'm gonna submit one more time because I'm chasing that 0 milliseconds. I got it that one time, and I'm like, oh, I want to get it again, but oh no, man. Sometimes this doesn't even give me. Jeez, this really has a lot of variation, huh? It was a few times it was the fastest solution, but then oh no, oh no, it's going so much slower now all of a sudden. I don't know. It was 0 milliseconds just a moment ago. Same code, basically. Okay, there we go. 6 milliseconds. All right. So yeah, it's a little bit of randomness involved here, but it's still pretty good. Still very impressive. All right, let's keep going. Build an array with stack operations. You're given an integer array target and an integer n. You have an empty stack with the two following operations. Push pushes an integer to the top of the stack. Pop removes the integer on the top of the stack. Also have a stream of the integers in the range 1 to n. Use the two stack operations to make the numbers in the stack from the bottom to the top equal to target. You should follow the following rules. In this, if the stream of the integers is not empty, pick the integer from the stream and push it to the top of the stack. Okay, if the stack is not empty, pop the integer at the top of the stack. If at any moment the elements in the stack from the bottom to the top are equal to target, do not read new integers in the stream and do not do more operations on the stack. Turn the stack operations needed to build target following the mentioned rules. There are multiple valid answers. Return any. The target 1, 3, n is 3. Wait, what? Oh, an integer array target. Oh, I see. Okay, an integer n. Stream of the integers in the range 1 to n. So output push, push, pop, push. Oh, interesting. So read from the stream, push on the stack. Read 2, pop 2, read 3. Oh, okay. Push, push, push. 1, 2, 3. Push, push. Uh, hmm. Target is from 1 to 100. Target is strictly. I was gonna say, oh, okay. Well, basically just pop the elements that you don't need. So this is just gonna be vector strings, pushes and pops. Okay. So std vector string result. It's basically gonna be, we're gonna buffer this too. Not buffer, but we can it's gonna be again bit shifted to the left. I think it's just pushes and pops, right? Yeah. Okay. So int I is 0. The target, yeah, the target value is going to be from 1 to n. Okay. So we're going to have current. I think we can do it this way. Current, it's like a mex type of thing. So current starts off at 1. I is going to be, I guess, 1. Then I is listed for the n. Okay. So if, oh, no, I should be 0. Target size. So, okay. Constant val is going to be target I. We're going to say 4. Current less than val. We're going to push, and we're going to pop. So every value, so we get our initial target value, and everything until we get to that point, we're going to push and pop. If current equals value, so let that push back, push. Okay. And then finally we increment I. I think that's it. It's that simple. Let's see how this goes. Let's see. How are we doing on time? Stream health time. It's been an hour and 50 minutes. Okay. Spent a good amount of time. I think a little bit of buffering, but not terrible. Wrong answer. Okay. So I got push, pop, push. Okay. Excuse me. I think we have to increment current here. That might be an issue there. Yeah, okay. I think this is it. I'm going to go for it. This is probably it. It's probably that simple. Okay, it's accepted. And these are very small test cases, so it's going to be fast too. Okay, that's fine. Don't need to get crazy with this. Sort array by increasing frequency. Given array of integers num, sort the array in increasing order based on the frequency of the values. Multiple values of the same frequency, sort them in decreasing order. Turn the sorted array. Okay, so the largest values first. Okay, interesting. Okay, and the nums are small, so we can use a frequency map to do this, simple frequency map to do this. Okay, this isn't too bad. We could just use a standard sort as well. So we'll do static int frequency 101, or it's 201, I think. Starts off at 0. Thread local. That way the AI doesn't complain to me that these are AI doesn't complain to me that these are unsafe for multi-threaded applications. Let's see, x plus 100. Okay. I'm going to use a more sophisticated lambda expression here. It's going to say constant x or a, constant b. It's going to be return frequency of a is less than frequency of b. And or frequency of a equals frequency of b. These have to add 100, I think, or I have to add 100 to shift this over. Yeah, a lot of extra additions going on here, but not the worst. And a greater than v. So that's decreasing sequence rather than increasing. Yeah, kind of interesting. Let's see what this looks like. Okay, let's go for it. I think it's right. Let's see. This may or may not be correct. I may have made a mistake. Oh, it's right. 100%. Yeah, it should be pretty fast. Those are very, very small test cases. Largest combination with bitwise and greater than 0. Okay, bitwise and of an array nums, the bitwise and of all integers and nums. Okay. That's usually really small, by the way. This is super, and is a like almost exponentially reducing kind of a operation. On average, the average case when you AND a bunch of bits together is like more than half the bits disappear. At each operation, each AND. So, okay. Combinations of elements in candidates array. Turn the size of the largest combination of candidates with a bitwise AND greater than 0. Should they be in subset of elements? It's not the same thing as combination. Combination is not the same thing as a subset. It's close, but it's not quite the same thing. Okay. So the largest subset with a positive, a non-zero AND, bitwise AND. Holy smokes, it's huge. Excuse me, whoa. Whoa. Oh, wow. Okay. I don't know the answer to this one offhand. This is definitely a challenging one. Whoa. Okay. Interesting. Actually, the easiest way to do this is to just pick a bit and then figure out the largest number of elements that have a bit in that spot. Yeah, we could do a bit. We just pick the bits. We have only 32 options to pick from. Okay, interesting. Very interesting. But we would say, yeah, in order for it to be non-zero, we just need one bit to work. So we could say, what do we say? It's going to be 10 million, I think. How many bits are in from 10 million? I think it's 2 to the 10th is 1,000, 2 to the 20th is 1,000,000. 22 multiplied by 4, get like 4 million. 23, 8, 24 bits. 2 to the 24th. That's probably enough. Bits. 24. Might want to change that later. Okay. So we're gonna go bit by bit. Bit frequency of bits. So that's 0. Gonna mem set. And then the result is going to be int result 0. Just take the maximum over the, actually you can even do better than that. I think I can do it this way. I could be wrong about this, I'm not sure. I'll have to double check if that works at the end there. And we're going to say, okay, for each constant x and candidates, then we're going to say int size 0, I is less than bits, bit equals 1, and I, bit shift 1. We're going to say bit frequency of I plus equals bit and it's going to be static cast full bit and x. It's something like this. Let me see if this even works, even if it even compiles. So no, okay. Not a function or pointer. Ooh, which one is this? Int is not a function or function pointer. Okay. Yeah. Can't quite use max element on this. Let me see. How do I use, take a look at this. I'd like to use the max routine. Not quite appropriate. This, what do you think? Yeah, I didn't want to write the whole loop out. I mean, I could just write the loop, the raw loop. Kind of would prefer if I could just use this a little more directly, use the std max element. So I'm still unable to make calculator in Python. What's up, Sonny Dixit? Can't make a calculator in Python. Can't make a calculator in Python. You're gonna need some GUI libraries, I think. I think hola. Inglés, por favor. Confused my confused my AI, man. Oh my gosh. Hello. All right. Range is max. And max. I have to read the pilot. Yeah, it is that line. Yeah. I was trying to get the max element over an array. Mm-hmm. Const correctness, maybe. Custom comparator. Oh, I know what it is. think that's it. Is that the problem? Oh, it was. Okay, let's go for it. I think this is correct. I'm going to go for it. I actually should have taken a little more time to think about it. Oh, it's right. Okay. Yeah, there you go. Pretty fast. Not the fastest, but pretty reasonable. I think it's okay. Is there a faster way to do this? I don't know. This is pretty fast. Message retracted. Wait, do you remember that girl I was talking about who I've been ignoring? I do remember you mentioned use asterisk. Oh yeah. I do remember you mentioned that there was a woman that you were interested or that was interested in you and you weren't sure how to let her down easy. Something like that. Something along those lines, and don't quote me on that. Mm, but I want the fastest. Try to get the fastest solution. Yeah, let's look at the fastest one. Zero milliseconds. Wow. Okay. Make it faster. Eliminating this call on the thread local array overhead. During counting. Stack allocation is faster for small arrays. Oh. This is max inline. It's fast and simpler than max element on all arrays. Oh. Even faster single pass. While counting. Second loop entirely. Why this is faster? Huh. Should give you the best runtime. Oh. I saw this one. See this one. Mm-hmm. All right, so I had the right idea. Okay. So I don't need this. And I don't need this. I don't need this. And I already know it's 24. I don't need this. And the other part I don't need either. Okay. How about this one? What's up, Gemini AI by Ankit? Hope your day's going well. Welcome. I was just joking before, by the way, about setting the calculator in Python's easy. Probably just need a GUI framework to make it a little bit easier, I guess. She just proposed. Damn it, what do I do? Holy smokes. Oh my gosh. I would probably say no. I don't mean to be flippant about it, but I would be like, no, I'm not ready to get married yet. Holy shit. Oh, Jesus. Being more serious about this. Sorry, you're in a tough spot there. Obviously, if you don't want to get married to her, that's a really difficult position to be in. I have no idea what you do in that situation. I wouldn't say yes, though, personally, unless you want to get married. I guess it depends. I'd have to know more about the situation to really give better advice. I think any advice I give is probably not great advice. On that, to be totally blunt, ChatGPT is faster and accurate than Brave Copilot. Use ChatGPT. I don't like ChatGPT. You know why I don't like ChatGPT? I don't. First things first, I don't think it's going to be free for very much longer. Second thing, I don't think they're really private either. At least the Brave one is. What am I? Oh yeah, at least the Brave one's a little more. Oh, what happened here? At least the Brave one's a little more. What did this suggest? It's at least supposed to be. It's at least supposed to be. I have to make this a bool, I think. Oh, and one. Oh. Oh. Oh, that's so much better. I didn't see that. I was like, wait a minute, what did I do? Oh. That's a good way of doing it. I didn't think about that. That's the way I should be doing it. Yeah, at least this is supposed to be private. Encrypted and private and all that good stuff. At least in theory. Oh, it's so fast now. It's almost 100%. So close. So close. I'll try one more time. Oh. All right, let's do this. It's bit shift equals 1 on x. Do x and I. X and 1. Let's try that. That might be a little bit better. I don't know if that's better, but it might be. I don't know. I got 4 milliseconds before. No. Let's try this. I'm going to do this one again. All right, I'm going to try this one more time. I think this is actually a little bit less work overall. So it should be, in theory, a little bit faster. Also, my computer's warm. 6 milliseconds. Not quite 0 milliseconds. This is very concise, but not the fastest. Not getting the 100%. Like, okay, there we go. See more of my body. Okay. Hey man, love from India. I'm stuck on second largest element in array. Help me. Yeah, it's not that hard. Let me tell you. Let me tell you. Give me 1 second though. I'm trying to optimize this here. How do I? Okay, hold on. One I posted, I think, got 0 seconds. Well, this one closer, but not quite 0 seconds. Let me see. Let me see. Let me see. I'll address some. Come back to chat in a minute. Okay, hold on. All right. Okay, this is the fastest. Std array, candidate, memo plus equals std betset candidate test I 0 1 largest. It's almost the same thing. It's really similar, not quite the same. It's actually slower. Huh. Interesting. Why this is faster? Huh. Huh. Interesting. Two subtle factors. Okay. Let me try again. Hidden bottleneck, even though it's optimized on raw, still has function call overhead, iterator arithmetic. Turns an iterator that you dereference. Manual max tracking is faster for tiny arrays because the compiler can fully inline optimize it. 0 millisecond solution. No second pass. Why this beats your version? Inline std max. Runtime hack. Bit manipulation is already optimal. Huh. Okay, hold on. Oh, it's so close. It's so close. I don't know, man. I don't know why. Can't beat the fastest solution. I can't do it. No, I can't do it. I don't see it. I mean, the other solution was very similar, except it used bit sets. Why would the bit set solution be faster? Oh, it's running so slow now. Oh, all right. What's up, chat? I don't want to break a girl's heart. Love is not for me. I've never talked to her. She's from a different major. I have no feelings for her, nor do I want to fake it or waste my time. Let's just ignore her. Yeah, that's crazy, man. Hey, man, love from India. Oh, yeah, thank you. Stuck on second largest element in array. Help me. that one's not too hard. What I like to do is you have an array of 2 elements, and what you're going to do is you're going to keep them sorted, right? From Dhaka, Bangladesh. What's up, Salam? Hello, welcome. Howdy. You're going to have 2 elements, and you're going to keep them sorted. So there's one that's smaller, one that's larger, and you know where they are. Sort them in ascending order. So the first element's always the smallest. You're going to go element by element and compare to the smallest element. If your new element is larger, then you're going to swap your new element with you're going to change the smaller element to your new element. Now you've got to check that element against the larger one. And if they're now out of order, you've got to swap them. If they're not out of order, you leave them. And you do it that way. Then when you're done, the second largest element should be the smaller of the 2. Sorry, it's not the smallest element, it's the smaller of the 2 elements. So yeah, when you see a larger element, it just has to be larger than the smaller of the 2. And then if it's larger than both, then you update the largest. Brother, you planning for Fang? What's up, man? I'm sorry. I already said hello. I have a bad habit of, like, whenever I read a message, it's just immediately say hello. Even if I've already said hello. Not for Fang. Although Fang is not a bad idea. So that's the second largest element, in short. That's how I like to do it. We were just on social media, hardly ever liked her posts. Oh no, she proposed to you. That's pretty wild. Remove std, no need. Remove std, it will be 0 milliseconds. Okay. That won't improve the speed. And while it's not necessary, I don't like to pollute the namespace, so I like to just, out of habit, make sure I add the, it's not really necessary, but I like to do it that way. So there you go. Okay. All right, we got some buffering going on, as I do. Idea, I'll ask her to wait, and I'll keep on asking to wait until she gives up. You could do it that way. I mean, easier would be to just tell her directly, but she'll get the hint. Yeah, you don't have to. If you're afraid of, like, some kind of backlash, you could just, I wouldn't say tell her to wait, but you just basically take time with your responses. One way of doing it is like, well, maybe I'll think about it later, you know. You just let me think about it later, and you just never get back to her, and eventually she'll move on and do something else. Lose interest. Come up with an answer later. Think about it later. But you don't have to say you have an answer later. You just say, let me think about it. And then when they say, what'd you think about it? You say, well, I didn't really have time to think about it. I was thinking about some other stuff, so let me think about it later. Not really a good thing, but you could do it that way. Better thing is just say, like, I'm sorry. You know, it's nice thought, but maybe not. DSA installing LeetCode, stuck on backtracking. Awesome, dude. Yeah, LeetCode's great for DSA. Oh, I'm so close. Oh, oh, so close. Backtracking's cool, dude. The deal with backtracking is you have a state, and you're going to modify the state before you recurse, and then after the recursion, you go back to the state you were at previously. So you move forward, recurse, and then move backwards in the state. What's the word? It's not update. It's you update the state, and then you roll back the update. That's what it is. You roll back. So you update, recurse, roll back. And that's the whole trick to backtracking. As long as you program that correctly, it's actually pretty easy. And a lot of programming languages support, like, stack allocation, where all the data to roll back is on the stack. So even after when the recursion completes, you still have whatever variables that you've set before the recursion, so you can always just roll back the state pretty easily. So it's actually very straightforward in most programming languages, especially C++. It definitely works very well. I'm so close, man. I'm so close. All right, so okay, so I asked the AI why Why? Unrelated to raw performance. So it's probably wrong about this, by the way. It's been wrong before where I'm like, why is it slower or faster? And it just doesn't give me the right answer. Tell me the fastest solution. Make no mistakes. All right. Okay. Here we go. All right. Whoops. So this is apparently the fastest solution. We're going to try it. See if it isn't indeed the fastest. Whoops. Oh, no. Didn't mean to do that. Let's see. See if we can get 0 milliseconds again. Or ourselves. Zero. Oh, no. Mine was faster. I guess he did just submit it like a ton of times until he got 0. Oh, mine's faster. Or mine's about as fast. No. Nope. The one I had was just fine. Huh. Jeez, man. Well, golly. Well, golly. I think if I just kept running mine, I would eventually get the correct that it gets is 100 milliseconds, 0 milliseconds, 100%. Oh, okay. Not that time. Oh, man. Let's go look at that one again. What did he do? The bit sets. He basically did the same thing, except used a bit set instead of direct bit manipulation. All right. I think we'll move on. I'm not sure if it's worth trying to run this repeatedly until I get 100. It's a little bit of a bummer not to get 100%, but this one seems to be I don't know. I don't know why, but for some reason it's a little bit harder. Yeah, it's so close. It's so close. I got 3 milliseconds. It's the best I got. Best way to practice and master recursion and BT at a time. Practice, man. Just keep practicing. I would say reading other people's code is good too. Like read their code and see, like read the solutions and see what people did, and you'll get a better sense of. Also, you could dump it into an AI assistant and ask like, hey, what's going on here? All right, we're gonna move on. We're gonna move on. I'm not gonna keep rolling until I get 0 milliseconds. It's a little much. It's a little much. Okay, but that was an interesting question, no less. That was interesting. Number of changing keys. Given a zero index string S typed by a user, changing a key is defined as using a key different from the last used key. For example, S equals AB has a change of a key, while S equals B, lowercase b does not have any. Return the. Hold on a second. Okay, all right, fine. Return the number of times the user had to change the key. Shift and caps lock won't be counted in changing the key. That is, if a user typed the letter A and then capital A, then it will not be considered changing the key. Okay, so I mean, I could just like make the keys what's the word, like case insensitive. So 0A to capital A, no change. Output is 2. So we change once to B and then once to C. Okay. 100 characters, only uppercase to lowercase. All right, so there's kind of a trick you could do here. So this is pretty straightforward. We're going to do it like so. Int result 0 for size. So we just need to be able to look ahead. Actually, look behind is fine too. So S minus 1 is not equal to S phi. It's almost this, except it's going to be, we're going to make them lowercase. Just make them both lowercase. That's kind of a bit hack, bit manipulation thing that I learned a while back. Let's see. Oops. I think it's right. Let's try it. Let's go for it. Yeah, that's pretty straightforward. 100%. Not bad. All right. We don't have to keep trying for 20 minutes trying to get the maximum there. Maximum sum with exactly k elements. You're given a 0 index integer array nums and integer k. Your task is to perform the following operation exactly k times in order to maximize your score. 0 index numbers, nums, integer k, exactly k times. Select an element from nums, remove the selected element from the array, add a new element with a value of m plus 1 to the array, increase your score by m. Interesting. Okay. Oh, interesting. Okay. Yeah, this is pretty easy. You can do let's do some math manipulation on this one. Let me see something. How are we doing on time? So that one, you're gonna find the maximum first. So we got another house, still have a half hour. Or still kind of still kind of buffering. So we get the max element, and then we're going to return, it's going to be this max element k times, plus not k, but k times k plus 1, bit shifted to the right, 1. And we assume k is small enough to do this. The k is on the smaller side. All these elements are on the smaller side. Wrong answer. Okay. But yeah, actually it's k minus 1. Okay, plus 1. Yeah, that's the right answer. The reason for that is that we're going to add the largest element, and then that's going to be the next largest, and you're going to as you add 1 to it, and so we're going to keep picking the same largest element over and over again, which means we're going to add that repeatedly, and then we're also going to add, as you add 1, 2, 3, etc. Those are going to be added together. So you group that together. The sum 1, 2, 3, etc. up to k. It's going to be the sum from 1 to k minus 1, which is k times k minus 1 divided by 2. And then also k times the maximum value. Why is this so slow, though? Why is this so slow? There we go. Okay, I was going to say I should get 0 milliseconds at some point here. Pretty good. Pretty good. Decrypt string from alphabet to integer mapping. You're given a string S formed by digits and pound. Want to map S to English lowercase characters as follows. Characters A to I represented by 1 to 9 respectively. Characters J to A represented by 10 to 26 pound respectively. Return the string formatted after mapping. In this case, okay. This isn't too bad. I think we just 2 English lowercase letters. I think it's mapping from here to there. Oh, I see. Okay. Got it. Whoa. Okay. I have to look ahead a little bit. That's interesting. Okay. This one's not too bad. This should be relatively straightforward. Let me let's go for this one. So we're going to do a pretty straightforward thing here. String results. Observe. Results. So if I plus 3 is less than this size, we can say end. S of I plus 3 equals nums. There's I plus 1, I plus 2, should be S plus I plus 2. It's going to be result plus equals A, B, C, D, E, F, G, H, I, J. Okay. So the I plus 1 is the tens place plus 2, or excuse me, I is the tens place. I plus 1 is the ones place, and convert that to a character. Otherwise, we just take S of I minus 0. Yeah, something like this I think is fine. Let's try this. See how this goes. Oh, I made a mistake. That's wrong. Here we increment by 3. Here we increment by 1. Yeah, that'll loop forever, I think, if I don't do it that way, if I don't forget to do it. Okay, what did I get? What did I do? KLBC, and it should have been JKAB. It's off by 1. Oh, it's 1 to 9. I think that, oh, this also might be 1. Let me see. Yeah, it's subtle, huh? Yeah, it's not mapping 0 to 25. It's mapping 1 to 26. So we subtract an extra 1 here. Interesting. Let's see if it's correct. It may or may not be correct. I don't know. There might be something subtle here I'm not realizing. Oh, it's fine. 100%. It's pretty good. All right. I think we just keep going. How am I doing on time? Okay, I got another 20 minutes. I think we could go further. Doing okay. Divide an array into subarrays with a minimum cost of 1. Give an array of integers, nums, and length n. The cost of an array is the value of its first element. For example, the cost of 1, 2, 3 is 1, while the cost of 3, 4, 1 is 3. Divide nums into 3 disjoint contiguous subarrays, return the minimum possible sum of the cost of subarrays. I mean, it's just the bottom three elements, right? Okay. Yeah, I mean, n is so small that we could just sort and take the bottom three. So we'll do that. Okay, let's see how this goes. This one's kind of on the easier side for sure. Wrong answer. Interesting. I did this wrong. I did it wrong. It's no. What I'm describing is not correct. Well, you always have to have the first element. Now you have the option to pick the next element, and the element, yeah, never mind. This is wrong. It's close, but it's slightly off. No, still wrong. Okay. Something like this. Okay. That's confusing. Try one more time. There you go. Okay, yeah, so real simple. The logic here is pretty straightforward. What you do is it's got to be three, it's a partition of three arrays. I kind of misunderstood. It's a partition of three arrays. So the first element's always going to be, and it says the cost is going to be minimized. The cost is just the first element of the array. So no matter what you pick, you're always picking the first element of the array, no matter what partition you pick. So that gets skipped from the sorting. And then again, there's a very small number of elements that we're working with, so the sort's very quick. Then what you're going to do is the first element you have to take, but the next part of the partition, you can pick any element to the right side that you want, and that can become the beginning element of the next part of the partition, the next subarray. And then to the right of that, you can pick the next whatever element you want again. Now, as long as you pick two elements that aren't the same element, so as long as they have different indices, you basically can pick whatever two elements you want to the right, and then just align the partition appropriately. So then you can just sort and grab those two smallest elements. So skipping by skipping the first element, and then grabbing those two smallest ones, and that's it. Very straightforward. Oh, hard question. Okay. Number of ways to paint an n×3 grid. Okay, you have a grid of size n×3, and you want to paint each cell of the grid with exactly one of three colors, red, yellow, or green, while making sure no two adjacent cells have the same color. No two cells that share vertical or horizontal sides have the same color. Given n, the number of rows of the grid, return the number of ways you can paint the grid. As the answer may grow large, the answer must be computed modulo a billion. Okay. It's an n by 3 grid. Input n equals 1, output is 12. 12 possible ways to paint the grid as shown on the show. Oh, I see. So the grid is 1 by 3. Okay. So the number of rows is n. And it's 5,000. It's a much larger number. And the grid length could be 1 to 5,000. And this is a very high acceptance rate. I don't know the answer immediately. It's a good question. It's a combinatorial question. It's one of the more challenging combinatorial types of questions, I think. Or no, I shouldn't say that. I don't actually know how challenging it is. If it's 80% acceptance rate, that's probably one of the easier ones. Okay, so no two adjacent cells of the same color, vertical or horizontal. Okay. All right. Let's think about how this could be done. Well, there's a brute force approach, which basically is backtracking. You pick a cell, paint it a color, and recurse on the next cell. And you can go through all the possibilities that way. And you obviously don't paint cells that you can't paint, and you backtrack when it's not possible to paint anything in a spot, which I guess could happen. That's probably pretty slow. There's probably a DP solution that's a little bit faster, I would guess. I would guess there's a DP solution that's pretty quick. Let's do the first case, the simplest case to start. So they say it's 12. 12 ways we could do this. So you've got red, yellow, red, red, green, red, red, yellow, green, red, green, yellow. And then you've got the like similar cases. So yellow, red, yellow instead of red, yellow, red, or green, red, green, or green, yellow, green, or it should be red, green, red, that one here. Basically when the first and second colors match. There's a few different cases. 1, 2, 3, 4, 5. Looks like half the cases are just that. Then if they don't match, then it's just 3 different colors in 6 different permutations. So yeah, that's 12. Interesting. Okay. Those are the only possible ways you can have a row, right? So each row, there's only those 12 possibilities. Then when you stack the rows on top of each other, things get a little bit more complex because the number of possible rows below, it's going to be for each one of these, you can select one of these 12, and one of those 12 will fit underneath. So a really straightforward thing to do is just compute the 12 by 12 variations, which ones are possible. You could run just a simple static routine that figures that out. And then you could use it basically like a state machine type of a deal. So yeah, there's a really straightforward DP solution, I think, for this. So it would be for each element of n, right, each n, you have the number of ways you have the 12 different choices. Then each of those when you want to add your next iteration, you're going to say the number of ways to get to each choice of that amount. Add all those are going to be added together, but the next iteration you're going to multiply by however many ways you're able. For example, however many ways you're able to get to red, yellow, red. Each of those red, yellow, red possibilities will contribute to the next iteration of whatever is possible, whatever is reachable from there. So like this red, yellow, red can't sit on top of this one, or this one, or this one, but it can sit on top of this one. So you would, for this choice, you would add the red, yellow, red choice. So sort of like you've got, like, I guess, previous choices or previous possible. You would add that here. So you can actually create you can use matrix multiplication for this. You can create a linear algebra problem out of this and actually do this in logarithmic time, I think. Yeah, you can use state transitions as matrices. And it's a matrix multiplication going from one state to the next. So each n plus one will be another state. And so you can actually use matrices and use either it'd still be logarithmic. It'd be log n time. You would do either use matrix exponentiation or exponentiate the matrix, which you can do in logarithmic time, or use, I forget what that's called. It's like binary exponentiation. Yeah, use binary exponentiation, or you could potentially perform the decomposition on the matrix to get the unit vectors and basically eigenvalue decomposition, and then exponentiate those eigenvalues and multiply each of the unit vectors and add them together. Both of those, though, I think is going to end up with binary exponentiation anyway, so I think you might as well just use the matrix multiplications. So yeah, I think state transitions is probably the easiest way to go, though. You don't need to. For this problem, you don't, because n is only from 1 to 5,000. You don't need to use logarithmic variations. You could just go O of n time. I just keep it very simple. So the state transitions are the thing. That's the thing we want, is the state transition. So if n equals 1, we're just going to return 12. It's going to be, let's do it this way. So we're going to do int previous 12. It's going to start off at 1, 1, 1, 1, or just 1 across the board. And then we're going to say current. Say 4, 0, decrement n, turn, stood, accumulate, current. Actually, this needs to be, we'll come back to that in a minute. Let's actually do this too. Yeah. n greater than 1. I guess the transitions are not that hard to figure out. So I mean, we could do it by hand. Do it by hand. It might be. I'm not sure which one's easier, quite frankly. The reason why it's not as easy doing it algorithmically is that, like, you kind of end up creating like a matrix and you have to do a matrix multiplication, which is kind of awkward, quite frankly. It's a little bit easier to just do it by hand and then hard code it. All right. So current 0 equals the following: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So this one, all of the combinations are going to be, it's going to be previous of, it's going to be potentially 12 of these. We'll do like 3 at a time. 3 per line. So this could take a while if you did this like this in an interview. But it's not the worst. And then take the whole thing mod. Like 7, 3, 4, 5, 6, 7, 8, 9. There you go. Okay. Oh man. So many. This is gonna take a while. Yeah, it's 144 combinations to go through. All right. Maybe it would have been better to write a small routine to do this. So we want red, yellow, red. What can I put this on underneath? Like if I had a row, what can I put underneath? Can't put. Let's do 0, 1, 2, 3, 4. Let's do it this way: 4 by 4 by 4. So 1, 2, 3 won't go under there. 4 works. 5 works. 6 works. 6 does not work. 7. It's fine. 8 is fine. 9 is fine. 8, 9, and that's it. Okay, that's not too bad. See, not too bad. Okay. Okay, what can go under 1? Can 0? No. 0, 1, 2, 3 immediately cannot. 4 can. 5 cannot. This is gonna take a while. 5 cannot. 6 can. 7 can. It's also very error prone. 8 can. About 9. 9 cannot. 10 cannot. Neither can 11. Okay. Okay. How about this one? So these 4 can't immediately. 1 can. 2 can, or 0, 1, 2, 3, 4 can, 5 can, 6 cannot, 7 cannot. 4 can and 5 can. 6 and 7 can't. 8. Oh shit. Sorry. Oh my gosh. Was that a panic attack? Jesus, man. I forgot what I'm sharing on my stream. Sorry, stream. Let me finish this one and then I'll read chat. Okay, hold on. So we said 1, 0, 1, 2, 3 cannot, 4 can, 5 can, 6 cannot, 7 cannot, 8 can, looks like. 9 can, 10 cannot, and 11 can. Okay. Today's a crazy day for me. I just politely messaged her that I like her as a friend. Now I'm going to start setting up the code for the internship assignment. Sure. You like her as a friend. There you go. That's beautiful. Perfect. Good luck. Good luck with the internship code. Yeah, definitely. It's pretty clear they expect you to use AI for that. So definitely use AI where you can, where it makes sense to do so. Although I'm not, I gave you that advice, but I actually don't know where. I don't know even how to do that myself. Where would it be most appropriate? I don't know. So 0, 1, 2, 3, 4 won't work for this one. Oh yeah, hold on. So 0, 1, 2, 3 won't. I could skip 0, 1, 2, and 3 on this one. Then can 4 skipped? 5 works. How about 6? 6 and 7 get skipped. How about 8? 8 gets skipped. What about 9? 9 works. How about 10? 10 works. And then the last one is 11. 11 works. Okay. I actually think this should be here. Yes, this is really error prone. I don't think this is the best way to do this. I think using an algorithm would have been better, but I'm not quite sure how I would have done that. I could think about it a little bit more, how I could have programmed this faster by using like rules to create the matrix, something like that. All right, so that was the first 4. Now the second row, second column gets skipped, but we can do 1 for sure, or 0. It's definitely one of the ones. So there's 0, then there's 1 works. 2 works, and 3 does not. Obviously 4 is itself, which it can't. 5, this whole row doesn't work, right? So I said 0, 1, 2, 3, 4, 5, 6, and 3, 4, 5, 6, 7 we skip. 8 we skip. 9 we skip. 10 works. And 11 works. Interesting. Okay. So that's the beginning of the second. Oops, did that. Okay. 5, so this one, 0 works. Does 1 work? 1 does not work. 2, We said 0 works. 1 does not work. 2 does work. What about 3? 3 also works. And then these all get skipped. 4, 5, 6, and 7 don't work. What about 8? 8 and 9 don't work. 10 maybe? 10 works. And then 11 does not work. Okay. So yeah, in the matrix, like these would be 0s and 1s, basically. Here, 0 does not work. 1 does work. 2 does not work. 3 does not work. 4, 5, 6, and 7 doesn't work. It's 2. Wait. 1 works. 2 doesn't work. Three works. 3 does not work. 4, 5, 6, and 7 don't work. 8 works. Right? 9 works. And 10 doesn't work. 11 works. 11 works. Okay. Okay. Last one here. So 0 works. Oh, this one. 1 works. 2 and 3 don't work. 4, 5, 6, and 7 don't work. 8 doesn't work. 9 does work. 10 works. 10 works. And 11 works. Okay. And we got the last 4. Making some progress here. Okay. So 0 works. 1 works. 2 works. And 3 does not work. 3 doesn't work. What about 4? 4 does not work. 5 doesn't work. 6 works. 6 works. And about 7. 7 doesn't work. And the rest of them don't work either. And we have a few more. Okay. So the second one, 9. 1 works. Does 2 work? 2 does not work. About 3. 3 works. 4. Or 0, 1, 2. Excuse me, it's 2. That should actually be 0, this first one. 0 works. 1 doesn't work. 2 works. 3 works. 4 doesn't work. 5 doesn't work. 6 works. A little odd, but it works. And what about 7? 7's the only one left that can work. 7 works. And last two. The first one doesn't work. Second, so 0 doesn't work. 1 doesn't work. 2 doesn't work. 3 works. 4 works. 5 works. 6 does not work. 7 works. And the rest of them cannot work. Okay. Here's the hoping that this is correct. I did it by hand, so it's pretty hard to... I may have to double check. Maybe I should have written some code. I might write some code afterwards just to see what it would have been like and how hard it would have been. Yeah. I probably should have written some code for this actually being a little more... Okay, all right, we'll come back to that. So for the green one, 0 and 1 don't work. 2 works just fine. 3 works. What about 4? 4 works. 5 does not work. 6 works. 7 exactly works. Okay, so that's it for so the current will be based off of the updated based off the previous, and then we're going to write the current to the previous. Yeah. And then we take the sum of the current, so something like this. If it compiles, memset, memeset. Oh yes, the meme set. Setting memes, definitely not a bad call. Runtime error, okay. Probably should have written code to automatically generate this. Oh, it's going to overflow now, huh? Okay. Oh yeah, I'm adding 1 billion 1, 2, 3, 4, 5 times. Right, that's a good point. That's a good point. Thought it wouldn't overflow, but I didn't think that all the way through. Also, how large are these end values? Oh, 5,000. Okay. I was gonna say, I was like, well, how big is this number? It might be easier to just make these longs, long. Yeah, we'll just make them long. This is simple. There may be, I could just put an extra modulo operation in there, but I think just using longs keeps it simple. Okay, it's wrong. And is 1. What happened there? What happened there? Okay. What is n? N is an int. And this 1 is greater than 1. What? Shouldn't this give me 12? What happened there? Gives me something way different than 12. Should this be... Huh? What is going on? What is happening? What's up, chat? I basically ignored chat for several minutes there. Don't know the answer, just mess around and find around. Yeah, I mean, sort of. It's a little more complicated. Not complicated, I shouldn't say it's more complicated than that. Oh, what happened here? What is this? What? Wait, what? Huh? What is going on with this? What in the world? Huh? Oh, maybe. Wait, what? I don't understand what's happening. The heck is going on? Hmm. What is going on? Okay, something weird is happening here. This for loop should skip. What the heck? Hold on. Something going on here. I don't understand what's happening. Didn't maybe I'm just getting tired here. I thought I copied this one. No. Huh? Why is my printout giving me... What in the world? Oh, that's why. Oh, that's because I don't know what's going on in my brain today. I think I'm getting maybe a little worn out here. Oh. I see. Okay. Setting bytes, not values. Okay. It's every byte to... I don't know. Okay. Excuse me. Got it. Okay, don't use memset for that. All right, that's indeed there was something I misunderstood. Indeed, there was something I misunderstood there. Oh boy. Oh, that's funny. Shucks, man. Whoops. Whoops. Okay. Yeah, I mean, trying stuff helps. If you're not sure about something, trying things does help. Okay. So, this one gives the right answer. Okay. I was like, at the very least, this should give me the correct answer for that case. These cases, however, things get a little more complex. So, maybe make this long one too. Okay, it shouldn't be negative. That shouldn't be happening. That shouldn't be happening. Hmm. Oh, why I'm getting negative numbers. Huh. Basically, it's overflowing somewhere. But how? Why? Um. The long should definitely handle 5 billion or so. So this doesn't make a lot of sense. Hmm. What can be significantly optimized by recognizing a key mathematical property that 12 states can be reduced to just 2? Oh, you're kidding. Oh my gosh. Wow. The matrix exponentiation would be even faster, yeah. The 3-column grid, all valid colorings fall into 2 symmetric categories. 3 color patterns, 2 color patterns. Transitions simplified to the new 3 color is 2 times the old 3 color plus 2 times the old 2 color. And the new 2 color is 2 times the old 3 color is 3 times the old 2 color. Wow. That is a lot simpler. I didn't think of that, see that. I was mostly concerned about code skipping, but that's good to know too. Yeah, I kind of just wanted to solve it first, and then I could think about more better optimizations later. Oh, safe from overflow. Hmm. Um. Yep, mine is overflowing. Huh. What is going on? Okay. Interesting. I don't know what I did. Did something wrong here. Oh, it's overflowing the accumulation function. That's what's overflowing. Ah, I see. Uh, it's so subtle. That's so easy to miss. It's a type deduction bug. Oh, that's my fault. That's, I don't know why. I must be getting tired or something. Oh, it overflowed on the return, so my code was fine. It's just when I returned something larger than int because I added 12 things that could have been a billion each, which would overflow. Ah, okay. Got it. Oh, it's correct. Cool. Looks like I got those state transitions correct. That's pretty amazing. Let me just try a few more test cases, and then so there you go. That's one way of doing this. Not the best way to do it, I think, but it works. Or so it seems. So, a few things to discuss about this. First things first, let's submit the solution and see what happens here. Okay, it's correct. It's correct, but not the fastest. Okay. So I think if I submit it a few times, it'll eventually reach 0 milliseconds. Or we get very close, 1 millisecond. Yeah, it's on the slower side. So this is one way of solving it. Not the best way to solve it, but it works. And you could use like I said, you could actually automate the state transitions. Now, as it turns out, on closer inspection, the off by one modulo mistake, yeah, the two-state reduction is basically, I kind of said that before, that if you organize this on 6 different two color cases and the 6 different 3-color cases, the 2-color cases, it looks like, can be combined with all the other 2-color cases, or almost, or a certain number of the other 2-color cases, or yeah. So this one can't be combined with this one, but it can be combined with 1, 2, and 3. No, 3. 2 of the other 2-color cases. Yeah, this is pretty confusing. Why? Can you help explain? 12-state solution. Yeah, it's not obvious at all, actually. It's really not obvious. Going to take my own advice. There you go. Though English is my second language, I strongly believe that I am not bad at it. I can form well-structured and grammatically correct sentences. My vocabulary isn't bad as well. Yeah, it's pretty good, actually. I did not even realize it's your second language. It's actually very good. Well, it may be different when you speak it. You know, it may be easier for me to see that, but that's very good. It's very good. So, all right, let's see. How do we reduce from 12 states to 2 states? Okay, symmetry. Pattern types, not specific colors. 3 columns, 3 colors. You initially identify 12 valid colorings for a single row. These fall into only 2 fundamental pattern types based on the structure ABA, first and third same. These examples. There's 6 of them, also called 2-color patterns. 0, 1, 0. There's 0, 1, 0, 0, 1, 2. Okay. Oh, there's another pattern which is all different. Why the specific colors don't matter. Transition rules depend only on the pattern type, not the specific colors. Row I is red, yellow, red, ABA. I plus 1 can be YRY, YGY, and GRG, 3 ABA patterns, or YRG, GRY, 2 ABC patterns. If row I is YGY, okay, hold on. For this symmetry to make sense, and reduce the states. Wouldn't the ABA patterns and the ABC patterns need to each have equal amounts? That is, RYR, well, has three ABA patterns, can transition to two ABC patterns. It will only be equivalent times previous ABA. ABC. I can also prove all of those patterns chosen have attribute the same amount, thus as opposed to their separate state contributions. Able to follow. I think the issue here is it's not obvious that you can easily prove that all of these states are equal. Like we treat all 6 ABA patterns as identical attributors and all 6 ABC patterns as identical attributors when calculating the next iteration. Concern is valid. For this formula to work, each pattern must contribute exactly the same amount to the next iteration's counts. Color permutation symmetry. Key is that the problem is invariant under color permutation. Transition rules are color agnostic. Okay. Both produce exactly 3 ABA plus 2 ABC successors. The bijection argument exists a color permutation that maps X pattern to Y. This permutation maps the 3 ABA successors of X, the 3 ABA successors of Y 1-to-1. Adjacency constraints depend only on same versus different, not specific colors. Permutation preserves validity. Proves equal contribution. Structurally identical. The number of valid successors depends on the pattern type, not the specific colors. Cool. Bottom line, the symmetry guarantees the patterns contribute identically. This is why we can collapse the states. Cool. Actually, my thinking here. It's not obvious that is the case. Asserted but not proven. No. I mean that the requirement for the different pattern contributions to be equal as long as they have the same pattern. It's not obvious. I'm not sure how to express this, but like that subtlety is not I'm not skeptical. Yes, I appreciate that you proved it. I just mean point out a subtlety highly non-obvious. Specific constraints usually break symmetry. Colorblind properties are rare. Reduction only works because the constraints purely adjacent cells must have different colors. This rule is blind to which colors are used. It only cares about equality versus inequality. Specific color blindness is what allows the permutation argument to hold. The reduction implicitly assumes that the set of valid next states for any ABA pattern is isomorphic to the set of valid states for any other ABA pattern. Proving this requires the bijection argument, which is a non-trivial step, often skip explanations. Cool. Very cool. Okay, so I can accept that the ABA patterns and ABC patterns all exactly the same amounts. To reduce to 2 states instead of 12. Why would this work? Why? How could I prove this? What are the arguments? Why the ABA patterns, ABC patterns contribute? My thinking is an inductive one. It's clear that it works. First case, one, since each pattern the same form, patterns, ABAs, I think 2 ABAs, I don't remember exactly the pattern, follows that they will all values again next iteration. Reduction, contributions. Okay, hold on. I explained it somewhere here. So the new ABA is 3 times the old ABA and 2 times the old ABC. And then ABC What about the ABC pattern? 2 and 2. So ABC is 2 and 2. Okay, so yeah, it can be proved by induction, I think. As long as you just go through each of the patterns to show that they have. Well, you don't actually have to go through all the patterns that have symmetry, so you don't even need to show that. You can just show that one of these patterns looks like this, and one of the other patterns looks like that. Inductive argument spot on. 2 pillars required. It's clear for the first row. 6 count is identical. Average contribution is also identical. For tracking the individual patterns, each of the would have a count of 1, and each of the 6 would have a count of 1. Start in perfect symmetry. Recurrence relation depends only on the type of the previous pattern, not on the specific colors used. Equal contribution, the number of ways to form a specific ABA pattern. Specific ABC pattern. All 6 specific patterns have the same count. All 6 specific patterns have the same count. Any specific pattern can be formed from previous predecessors. Symmetry exactly 3 and 2. Count for this pattern becomes 3 times 2. So every one has exactly the same number. Have the same count. Applies to ABC patterns. Induction hold perfectly. Base case, inductive step. Counts remain equal within each type at every iteration, summing them up, which is what the 12 two-state DP does. It's mathematically equivalent to tracking all 12 states individually. Don't just accept the symmetry, you've proven it for itself. Cool. Yeah, that's the way to do it, I think. When I have to walk others through my code, I can't do it as well as I can write it in docs. Oh, I see. Maybe I should start socializing with others and making videos myself. I mean, you can. You could try it. You could try it. It's up to you what you want to do. I'm not really sure what you should or shouldn't do there. Oh, okay. So let's take a look at, let's do the two-state solution. The two-state solution. Oh, YouTube, please. Don't hurt me. Don't hurt me. Gotta be careful with the words you use. Automated checks are gonna bot my video. Two-state DP, I should say. Oh boy. All right. So we'll say current ABA and use longs. Current ABC. Previous ABA. Previous ABC. So initially, we're going to start everything off with 6. Then we're going to say return current ABA plus current ABC mod. And we're going to do here is say current ABA equals current ABC equals previous ABA is current ABA, previous ABC is current ABC. All right. So if you had red, yellow, red, how many other ABAs can we get? We can do not this one. We can do yellow, red, yellow. That's 1. We can do yellow, green, yellow. That's 2. And we can do green, red, green. That's 3. Can't do green, yellow, green though. And we also can't do red, green, red. So I got 1, 2, 3. Yellow, green, yellow, green, yellow. Oh no, not yellow. Yeah, green, yellow, and green, red, green. And also yellow, red, green. Or yellow, red, yellow. So that's 3. So the current ABA, we're going to do 3 times previous ABA. And then for the ABCs, it's going to be not this one, not this one. That's 2 eliminated. There's this one. That's 1. And then there's another one, not this one. So that's, I think, 4 so far. So I got 1. It looks like 2. And that's it. There's 2. 2 previous ABCs. And basically by symmetry, they all the states have the same same transition pattern. And then for ABC, we can say, okay, how about the ABAs? So not this one, and not this one. And there's one here. That's one. This is also one. That's two. I think it's just two. Not a third or fourth. Yeah, it's just two. Two previous ABAs. And I already know it's two previous ABCs, but let's just double check. So previous ABCs, we can do not this one, not this one. This one works, that's one. And this one works, that's two, right? What about this one? This is not, no, and those ones don't work. So that's just two. Yeah. There you go. And all of the proof that I had before is that all of the different states initially are the same. All of the different states are initially the same, and all of them follow this pattern, which mean that they're always going to be the same, which means that their contributions are always the same, which means that this pattern can be applied as two states instead of 12, which is pretty interesting. Pretty interesting. There we go. That's 100%. That's a pretty interesting. This is a good question, man. This is a tough one. Not a tough one, but it's very subtle. It's really beautiful because of the symmetry, but it's also very easy to miss. Not that easy to spot. Kind of easy to miss. I'd say this reduction in state is very subtle. Very easy to miss that, but also it's there. I mean, once you see it, it's like, oh wow, that's pretty amazing. That's actually a really cool problem. That's a really cool problem. I like this a lot. This is a good place to stop too. How are we doing in terms of stream health here? Yeah, we're almost 4 hours. Let's do. I got a few more minutes. Let's do like 10 more minutes. I just want to say this is really cool. I would have seen this if I kept tinkering with this problem, because I did notice that some of the answers that were coming out in the states were equal to each other. That's something, I guess, to keep in mind. Like if you're working on a DP program that has states, you can show some of the states as you're working through the problem, and you might see patterns like certain states are always equal, which might reveal a faster reduction, a simplification. It's pretty amazing. But yeah, symmetry. Problems that have symmetry definitely should look for reductions. Like this one has pretty obvious symmetry. Sometimes they even have asymmetries that can help simplify things too. But yeah, the 12 different states where 6 of them are basically equal to another 6, or yeah, 6 of them are always equal, and the other 6 are always equal. Then it becomes more like 2 states. But interestingly, the calculation for the next state is related to the sum of the previous states, or sum of parts of the previous states, which are all going to be equal to each other. So that's kind of peculiar. I kind of wouldn't expect that, I suppose. Yeah. Yeah, this current ABA and current ABC calculation based on the previous ABC ABA and previous ABC every one of these states, it's going to have the same calculation. And every one of those states ends up giving you the same number. Yeah, interesting. Peculiar. Really, let me think about it a little bit more. There's something there. There's something to that. Yes. Okay. No, I understand now. So the each of those states has the same formula based off of the previous states, right? And what I'm looking for is the sum. So the sum of all of those states based off of the previous sum of all those states translates, and I end up with the sum of all those states at the end. That's very interesting. So basically, if I were to instead use 1 instead of 6s for all these initial values, I would end up with current ABA and current ABC. This formula would give me the correct answer for one of those 6 states. And I'd only have to multiply by 6 at the end to add it all together. However, because they all have the same formula, I can actually just start with 6 in the beginning as the sum of all of these instead of starting with 1. And I only have to calculate this formula once. So I could have alternatively just multiplied by 6 at the end. But I can also just start with 6. So that's a kind of a peculiarity too for the math here, why that works. It's easier to see it if you start with 1. But then you'd have to calculate this 6 times. So not have to calculate 6 times, but you can just multiply by 6 later. And alternatively, you could start by multiplying by 6 in the beginning. And that mathematically works out same thing. Ends up being the same deal. Which is pretty amazing. It's pretty amazing. Yeah. Cool. Very cool. Yeah, because they all have the same formula for each of those pieces, you can actually compute the entire sums in terms of the previous sums, which is a bit odd when you think about it, but it does work. Yeah, very interesting. Not obvious at all. Super interesting question. Wrapping your head around it. Oh my God. What's up, Adarsh Prajapati? What's up, man? Yeah, that's a pretty cool question. My mind's kind of blown, quite frankly. My mind is kind of blown thinking about it. Very cool. Very cool. All right, let's go to the next question. But yeah, wait, let me get 0 milliseconds before we go. So yeah, trying to explain that a few times or thinking about it a few different ways, like definitely pretty interesting. But I like the easiest way to think about it is that if you just did one state 6 times, it's much easier to think about. But then you can actually combine them all into a group of 6 states. Because at each iterative step, you can just add them all together anyway. So it's sort of like the basic, what's that called? The basic iteration. There's a term for that when something is defined in terms of, what do they call that? What are iterative functions called typically? Like f of n plus 1. I forgot what these are called, actually. I'm misremembering now. But what's interesting is that each of those 6 states being equal to each other and all having the same formula, recursive recurrence relations. Yes, recurrence relations. Yeah, they all have the same recurrence relation. The 6 states have the same current recurrence relation, and other 6 states have the same recurrence relation. And so if you add all those recurrence relations together, you end up with another recurrence relation, which is the same recurrence relation, but with just a different starting point. The starting point is just the sum. Yeah, I think that's it. I think that's the way to think about it, is that the 6 different states with the same recurrence relations, you add them together, they end up basically just being 6 times the original recurrence relation, which means you can just start from your values at 6 instead of 1. Use the same recurrence. Yeah, that's a little weird to think about. It's a bit mind-blowing. Seems kind of obvious on one level, but on another level it seems like kind of mind-blowing. Not obvious. Anyway, okay, moving on. Let's move on. I thought this was really cool. Let's move on. Let's do another question. I could see why that's considered an easier question. It's not that easy, but if you know the answer, it's super easy. It's hard to get that wrong. That's a very good question. Nested array generator. Okay, this is a JavaScript one. I think we'll do another one after this too. The JavaScript ones I'm not like a big fan of. Also, I don't know. Okay, let's check the chat. Given a multi-dimensional array of integers, return a generator object which yields integers in the same order as in-order traversal. A multi-dimensional array is a recursive data structure which contains both integers and other multi-dimensional arrays. In-order traversal iterates over each array from left to right, yielding any integers it encounters or applying in-order traversal to any arrays it encounters. Oh, that's interesting, huh? This actually is not that hard to implement, I think, by the way. So if they flatten the array, it's 100,000. Elements are between 0 and 100,000. The maximum nesting depth is 100,000. Can you solve this without creating a new flattened version of the array? I don't know. A generator function. Okay. I think it's yield, right? So I think we could make it recursive, yeah, maybe. I could try. Const in order should yield value I don't really know. What does the syntax do again? Actually, okay. How do I create? I create a function that references itself. Cursive lambda expressions in C++. What about JavaScript? I want to try to use a recursive lambda expression that does this, or a recursive function that does this. Named function expression. Variable references. Common with arrow functions. Cannot have an internal name. Deprecated. Okay, so named function, all right. Function name. Okay, we'll say internal function. And we want to say in order, yield in order. And the way this works is yeah, I'm not really sure. I don't know. I'm not gonna try this, I suppose. So the way this is going to work is the root node is going to be the array. So current equals the array. Then position is initially the beginning of the array. And I would say if position of, so it goes like this. If position is less than current length, then we can say const which item equals array of position, current of position. Then if item this is really tricky. In order, you do left subtree, node, right subtree. Yeah, okay. Um, huh. I don't know, man. Uh, huh. Yeah, I don't know. I'm not sure about this. Um, okay. So if position is less than array length and array of position is not I can't really think about this, huh? If it was a tree structure, it would be, like I said, left subtree. It was a multi-tree structure. It would be. It's still the same thing. It's just okay. I think that's the confusion. This is a multi-level tree or a multi-child tree, not a binary tree. But it's much easier with a binary tree. It's just left, center, right. It's left node, right. There are a few factors that make this a little bit more complicated. It's a tree structure with multiple children, which is a little bit different. And in order traversal of a tree structure with multiple children, it's going to be from left to right, but not necessarily left then right. So let's say you had a tree, like a ternary tree, right? So you had one node, three nodes, each of those had three nodes. The in order traversal is going to be, I think, process all the way down the left side first. Start with the left node. Actually, let's clarify this. In an in order traversal ternary tree rather than a binary tree. How is this typically defined? I think this is one of the elements here that's making this a little bit difficult for me to think about. Don't actually know how this is supposed to work. They are in order as a single standard definition, left root right. In order traversal for ternary or general n-ary trees is not universally standardized. Two common conventions exist: the left root, middle right convention. Dividing the children into left and right groups, placing the root after the first child subtree. All but last children root, last child convention. The root naturally sits between its only two children. Ternary tree, the root has three children. There's no single middle slot for the root to occupy relative. Definition depends on whether you view the root. Okay. Excuse me. Okay. And so for LeetCode 2649, I have this text. Hi, hold on. Uh, Okay, so let me. I didn't realize that. Oh yeah. Let me stop here. Actually, something just came up. Okay. I think I need to stop here. Let me just read chat quickly. Express gratitude. Thank you. Bid farewell. All right, take care, Yesh. It's getting late. Should probably hit the bed. Carpe diem. Yeah, man. Take care. Actually, I should get going too. This is an interesting question, but I need to take care of something that came up. So